Well, we've made it to graphing. So, I know most of us, we hear graphing and the first thought is, oh, okay. Trig graphing is a little different. For you, you're probably not going to even have to necessarily even make a graph. But you're going to have to be able to read one, and you're going to have to be able to recognize one. So I'll make the deal with you. You don't actually have to build one, like by hand, and draw it for me. But you're going to have to be able to recognize which graphs go with which equations. Basically, what you need to do in your online homework. Because really, we just need to know the parent functions of our graphs, for the most part. Do you know a parent function, like a parabola is parabola's parent function looks like this? You know what I mean? The cubic function looks like this. Parent functions. Well, in trig, at least in your teacher's opinion, just knowing our parent functions, I think, can go a long way. And not necessarily having to get too crazy into our transformations. Except this whole section is about those transformations. But again, I'm not going to ask you to graph it. I'm going to ask you to be able to read it and be able to do your online homework and then get an equation and say which graph goes to it. Or by giving you a graph and saying, hey, which equation goes with this? That requires knowledge and understanding of the whole function. So let's get into it. Here's your little lead in it. We're going to go to this. And I want to talk about the unit circle. Here we go. I've kind of drawn in the 0, pi over 2, pi, 3 pi over 2, in the background to 2 pi, or 0, or all the way around to 360. But we're going to really be speaking radians only. Only radians while we're in 1.5 and 1.6. When we graph, we don't dick around with degrees. It's just there's a reason behind it. So throw degrees out the frickin' window, or maybe convert so your brain sees it. Now I want to talk about the unit circle. We skipped over it, but I've talked about it just a bit. So let's take a circle with a radius of 1. And actually, hold on one moment. So let me do this. Let me get that off there just so you can see that that was just 1. And I'm going to take this thing. I'm going to superimpose it right on top of here. See if I can't get it right. Close enough. Close enough. So we're going to say that this is 1 unit. So this point here is 1, 0. This point here is 0, 1. This point here is -1, 0. And this point down here is 0, -1. Well, if we're on the unit circle, it actually, that's cosine's value and that's sine's value. Cosine's value, that's sine's value. Cosine's value, that's sine's value. Cosine's value, that's sine's value. That's big. That's gold, but that's only on the unit circle. And I keep kind of keeping you away from it. So let's just kind of see what we have. I'm going to just write down a few things and say that sine of 0 is equal to 0. I'm just going to talk about sine for a second. Sine of pi over 2 is equal to 1. Sine of pi is equal to 0. Sine of 3 pi over 2 is equal to -1. And sine of 2 pi is equal to 0. Back around in the circle. Now, let's play the same game with cosine. And just follow along. All I'm doing is saying sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And then back. I'm going to do that with cosine. Cosine of 0 is equal to 1. And these should be things we're starting to get down now. Maybe not perfect, but we're getting there. Cosine of pi, this is one of my favorites. I like using cosine of pi. I overuse that one. So knowing cosine of pi is -1 would be helpful. At least for just like passing tests and shit like that. Because I like to use it quite a bit. So there we go. We got some values. Cool. Cool. Well, we're going to start graphing. And you might be thinking, you're like, but what's that shit? Aren't we graphing? This is a trick. This right here is a trick. It's a tool. It's something we use. That is not the graph of sine or cosine or tangent or anything like that. It's a trick. It's this little helpful thing. But what we're going to think of is we're going to need to look at these equations just a tad bit differently. Now I'm going to write up above that we're going to start saying it just, I don't know, we've been saying sine of theta is equal to what? Like the y over the r value or something like that. We're going to look a little different. Now we're going to call the angle x. Or we're going to say sine of x is equal to y. Cosine of x is equal to y. And we're going to graph it in that manner. So let's look down at the bottom. If we say that y is equal to sine of x, we're saying that y is the ratio and x is the angle. And we're going to talk about the angle in radians. Once again, y is equal to cosine of x. We're going to say that y is the ratio and that x is the angle. Same thing. So x has now become our theta, right? X is theta because we're going to graph this on an x, y. So let's jump down. There we go. And once again, let's write out sine stuff. So for y is equal to sine of x. Let's start writing it down. So sine of, there's a little list. Sine of 0 is equal to 0. Sine of pi over 6. Oops, shit, not pi over 6. I don't want to go that way. I don't want to break it down that far. Sine of pi over 2, that's equal to 1. Sine of pi, that's equal to 0. Sine of 3 pi over 2, that's equal to -1. And of course, if you go back around in the circle, sine of 2 pi is going to be equal to 0. So these are your x and your y values. Your x and your y values. So here's all of your y values. Right through here. And here's all of your x values. Right through here. Oops. Put 0 back in there. All right. Let's graph it. So let's look at our first ordered pair. Our x is 0, our y is 0. 0, 0. Oh, let's write in that we're graphing y is equal to sine of x here. That's what we're graphing. So now we go to the next one. Oh, let me just write the ordered pairs out. X comma y. This one's 0, 0. For our next one, it's going to be pi over 2 comma 1. So let's write that in. Our x value next is pi over 2, and the height is 1. Cool. Our next one, our ordered pairs. We're going to look at it and go pi is our x value, and 0 is our y value. So let's call this one pi. Now the next one is 3 pi over 2. And the y value is -1. So let's call this one 3 pi over 2, or 270 degrees. And we'll make that point there. And then when we loop back around in the circle, we're going to say when you put in 2 pi, you're going to go to 0. And now, since sine repeats, this graph will go on forever and ever. So I just give you like the basics, like just my shitty drawing. You know? It's going to go like this, but it's going to keep this pattern. And it's just going to keep going forever. And this is going to be our graph of sine. Now, of course, this goes back the other direction too. Right down there, because negative pi over 2, well, that's the same as coterminal to 3 pi over 2. So they have the same answer. They're both at -1. Then it can pop right back up and go through. Now we'll lose this. And keep on going up. Now, if you're to play the same game with cosine, you find out you get a little separate of a graph. So this is what we call our parent function. This is just a parent function. That we should absolutely know what a sine wave looks like. And I bet most of us kind of have an idea what a sine wave looked like beforehand. You've seen it like what is it, like the hospitals and shit? They got the stuff that goes up and down, that monitors your heart. It's kind of like a sine wave, huh? I bet there's some models. So this is just kind of the basics as to what we're doing, how we're going from that weird circle thingy or using the quadrant game. And now we're going to build it to look like this. So I'm going to just give you the parent functions of the other ones, and then we're going to start to build it. And everything's going to be in like in a different form. But I just wanted to make sure that we get some sort of understanding of like tying together this weird ass circle or just that little excellent. Oops, don't look at that. You don't want to see that yet. Just how you tie x's and y's in with thetas and ratios. Hope it's helpful. The next one, we'll start building them up.